Hello students, today we are going to discuss about size effect in nanomaterials. So today I'll show you 3 videos which will tell you about what is happening to the size in 3 different properties, and based on that you can think on the other properties. For example, first of all we'll try to see what happens to the melting of an ice. So this video is a simulation how the melting progresses for an ice cube. Look carefully, observe carefully what is happening to the material. The corner molecule, they started falling off fast. The falling means it is melting, and as it progresses, as the size decreases, now see what is happening to the falling apart process or the melting process. Observe carefully. As shape changes, size decreases. Now carefully observe what is happening to the melting, the rate at which it melts. Now, this is what I was telling you. So how does it happen? Now you go to the next. We'll just make it a little more complicated. We'll have more surface. Now this is a square. The similar atoms we can take make into different complex shape with more surface area or surface atoms in the surface. That's okay. Now look at this. Here also corner atoms, which is exposed, only one side is attached to the main object or main part, they will start falling. Just look carefully. That's what I was telling you. Now you see the surface area is more here compared to that. The rate at which it melts also should differ. Initially it looks okay that it is not melting that fast, but now as it progresses there is a sudden increase. Look at this. Okay, now you have some idea. Now just observe carefully what will happen to the bulk. Even as the melting starts, the whole bulk starts melting, and the surface area where it is more exposed, that is more surface area, they are melting fast. Okay, now you have understanding the melting point or the melting of ice and this complex object depends on the size, or rather the surface area. Now we'll have a look at another property called diffusion, which is important from the point of view making most of the alloys and all. Now look at these two are different. This is one and this is a dopant that you are going to put it in different matrix. Now what is happening here? The particle is small, so it diffuses faster. So diffusivity depends on the material. Now look at what is happened to the solubility. Solubility means how a material dissolves in a solvent. Now for this we'll take a water molecule. In water we'll try to put sodium chloride, where sodium is a positive ion and chlorine is a negative. So that's it. And the water, as you all know, is also polar molecule with hydrogen being positive and oxygen being negative. So when they come in contact with this negative fluorine, the hydrogen will attach this and sodium oxygen will attach. Now this is how this dissolution happens. The positive part, they attack the negative chlorine atom, they pull it, and the negative charged part will attach the positive sodium atom. Now this is how they make, and they will not allow them to come together to form an ion, form an ionic crystal again. This is how the dissolution happens, and this phenomenon, it happens more or less on the surface. So now you think what will happen to the surface as you reduce the size, and similarly you can think upon other properties, like what will happen to the conductivity, what can happen to the magnetism as you reduce the size. So that will have different things also we need to take into consideration. And different things I mean to say is like quantum confinement also. That I will do in the next video. But you think about those property also. What will happen if you reduce the size? Now we have seen melting, we have seen dissolution, we have seen the diffusion. So these are all your thermal property. You can think also about, you can also think about what will happen to thermal conductivity, what will happen to the electrical conductivity. Okay, these are all physical properties. So just think about it, and tomorrow we can discuss in the class.